So this is the video for lesson 83, the unit circle, but we're actually going to start back on page 19 for the lesson 82 homework because this leads into what we're going to do. So if you need to pause the video if you didn't get the homework done or were confused by this, hopefully not, you were supposed to label points A through P like we did in the first lesson. We're going to go through a couple other steps. We're going to write the coordinates, the 4 points for the quadrantal angles. So this is partly going to be a homework check. This is 0, 1. -1, 0, and 0, -1. Now we're going to compare points D, B, and D, which one has the larger x value and the larger y value. So this is just a review. So if I look at B, B has the larger x value, and D has the larger y value. We're going to compare points C and G. So looking at C and G, what's the same about these 2 points and what's different? So if I look at C and G, they have the same height or y value. What's different about these 2 points, where it looks like they have the same absolute value for x, but C has a positive x value and G has a negative x. So very similar, but we do have that one part that's different. So I'm going to have to make this a little smaller so that we can see the directions. So I'm going to do that right now. So we're going to complete the following directions with point C. So it says draw a line from point C to the origin. So we're going to do that now. Draw a vertical line from C to the x-axis. So I kind of already have this when I was measuring the y value. You now have a triangle with its base on the x-axis. How long is the hypotenuse of the triangle? So my hypotenuse, because this is the unit circle with a radius of 1, so the hypotenuse is also 1. We're going to next label the base of the triangle x. And we're going to label the height of the triangle y. Okay. To correspond with the coordinates of point C. So if I was to label point C out here and say that its coordinates were x comma y, the x value would be equivalent to the base of the triangle and the y would be equivalent to the height of the triangle. Now we're going to label the angle in the triangle that is next to the origin. So I'm going to give that a theta. Okay, yeah, whatever. Okay, so each of these on your paper should say sine of theta, cosine tangent. So find the following trigonometric ratios using the 3 labeled sides. So when I talk about the sine of theta, if I look opposite angle theta, that's y. The hypotenuse is 1. So that actually reduces to just y. Cosine of theta, adjacent over hypotenuse, is x over 1. So x over 1, which is x, and tangent of theta is y over x. So a couple other questions that I'm going to scroll up for this part again. It says explain why the x coordinate and y coordinate of the point on the unit circle can never exceed 1. We just want to write the radius of the circle is 1. And we should note the center is 0, 0. So if my center was somewhere else, like at 5, 4 or something, that x and y value would definitely be bigger than 1, right? Because it's shifted over, but this is an important piece of the puzzle. So all of this information is going to help us on our next lesson. You can turn the... So we will be heading back to what we did in the homework. For now, we're going to continue to work on the radian measures. So I'm just going to kind of put in what I already have. It says you know the radian measures for all of these angles, which is actually a large chunk, and we're going to put them in now. So I'm going to pause the video. I'm not going to talk through everything. If you want to look back at both the first and second lessons, towards the end I did go over this. So this is what we know already, right? Basically, and one thing I should put on here is the 2 pi over here. Okay, so this is just working with the fractions. So for today's lesson, we're going to start working with the angles that are related to 30. So, and I just missed two things. Let me put them on. So 30 is pi over 6, and 45 or 60 is pi over 3. So we'll put those on. So the angles related to 30 are those that are 30 away from the x-axis. So to do this, we're going to add or subtract the radian measure for 30, which is pi over 6. And if we go off these values, this is going off pi over here. And on the other side, we're going off 2 pi. Okay, so this is just a little basic fraction work. We're going to start out with 150. So 150, I'm going to do pi minus pi over 6. So when we subtract fractions, we know we need an LCD. So I can see that's 6, so I'm going to multiply this fraction pi by 6 over 6. So that's going to give me 6 pi over 6 minus 1 pi over 6 is 6 minus 1 is 5 pi over 6. So this is going to be a 5 pi over 6 right here. Just going to erase a little bit here. You can go back and pause that if you need to, just because I'm going to kind of run into, I'm just going to write the answer here so we have it. But it's going to get crowded otherwise. So for the next one, we're going to do the 210. So now I have pi plus pi over 6 because we're getting larger. I'm just going to change this fraction here, multiply it by 6 over 6. So 6 plus 1 is 7 pi over 6, and that's what we're going to put right here. Okay, remember each of these is really like 5/6 pi and 7/6 pi. If you want to write them with the fraction off, we're leaving the fraction on. So lastly, I'm going to erase this work, and I'm going to do the other side. So over here at 330, that's 2 pi minus pi over 6 because it's getting smaller. So I'm once again going to multiply by 6 over 6. So this is 12 pi over 6 minus 1 pi over 6, right? 6 over 6 times 2 pi would give me 12 pi over 6. So that gives me 11 pi over 6. So that's what's going to go over here. So looking at this side, when I look at these different sections, I see that all of them are over 6. This is 1 smaller than 6 over 6, 1 bigger than 6 over 6. This is 1 smaller than 2 pi, which would be 12 pi over 6. So there's patterns in there that you can look for. So now we're going to try everything with the 60s. So for 60, right, we have pi over 3. And we are finding all of those related angles. So 120, 240, and 300. So here we're going to add or subtract pi over 3, right? Just like we added and subtracted pi over 6. And same deal from either pi or 2 pi, just to kind of keep our method the same. So I'm going to go a little bit more quickly through this. So if I am working with 120 and I do pi minus pi over 3, I'm going to create an LCD, multiply this one by 3 over 3. This is 1 pi over 3, so that's going to be 2 pi over 3. In the third quadrant, which is a separating line, I have pi plus pi over 3 because we're getting bigger, so I make this one 3 over 3 and put a 1 on, so that's 4 pi over 3. Okay, lastly, moving over to the 300, that's 2 pi minus pi over 3. Multiplying this by 3 over 3, we get 6 pi over 3 minus 1 pi over 3 is equal to 5 pi over 3. Okay, So at the bottom it says, note that even though we learned how to find radian measures for 135, 225, and 315 by thinking about fractions of a circle, so we counted around like 1/4, 2/4, 3/4, and so on, we could also add or subtract pi over 4 from either pi or 2 pi. Let me just move this up. So from either pi or 2 pi, sorry about the copying. I'm just going to talk through this. You could do the work from it. I find that, you know, either you like this subtracting method or you don't, so you could probably figure it out yourself. So here, with the yellows, here for 3 pi over 4, that's like 4 pi over 4 minus 1 pi over 4 is 3 pi over 4. 4 pi over 4 plus 1 pi over 4 is 5 pi over 4. And then 2 pi is equal to 8/4 pi, minus 1/4 would be 7 pi over 4.